Good day, everyone. My name is Errol Coder, and this is Planetary Television. We're back on Mars with an update from the Mars Exploration Rover Opportunity and the Mars Science Laboratory Curiosity. Now, Curiosity flexed its robotic arm today for the first time since before launch in November 2011. The 7-foot-long arm maneuvers a turret of tools including a camera, a drill, and a spectrometer, and a scoop and mechanisms for sieving and portioning samples of powdered rock and soil. We've had to sit tight for the first 2 weeks since landing, while other parts of the rover were checked out. So to see the arm extended in these images is a huge moment for us, said Matt Robinson of NASA's Jet Propulsion Laboratory, lead engineer for Curiosity's robotic arm testing and operations. The arm is how we are going to get samples into the laboratory instruments and how we place the other instruments onto service targets. Weeks of testing and calibrating arm movements are ahead before the arm delivers its first sample of Martian soil to the instruments inside the rover. Monday's maneuver checked motors and joints by unstowing the arm for the first time, extending it forward using all 5 joints, then stowing it again in preparation for the rover's first drive. It worked just as we planned, said Jet Propulsion Laboratories' Louise Chandira, Sample System Chief Engineer for Curiosity. From telemetry and from the images received this morning, we can confirm that the arm went to the positions we commanded it to go. Now, on the other part of Mars is the Mars Exploration Rover Opportunity. Our most recent update was received on August 7th. No new information has been provided from JPL, but as of that time, Opportunity is located at the north end of Cape York on the rim of the Endeavour crater. Activity has been constrained for the period around the arrival of Curiosity. The project pre-planned 9 sols of activity so as not to require Deep Space Network tracking coverage during the Mars Science Laboratory's entry, descent, and landing. Opportunity performed alpha particle X-ray spectrometry overnight integrations on sols 3030, 3031, 3033, and 3034, which was August 2nd, 3rd, 5th, and 6th of 2012. On the surface target Rush-Shaw 1. Multi-filter panoramic camera images were collected of Whim Creek on Sol 3031 and 3032, which was August 3rd and August 4th. Daily atmospheric opacency measurements were also performed. With Curiosity safely on the surface, the plan ahead for Opportunity is to resume driving. Now on to another subject many of you might not be aware of. NASA has delayed the launch of the twin spacecraft to study Earth's harsh radiation belts this week by 24 hours in order to iron out a possible glitch with the mission's rockets. Officials announced today, August 20th. The agency's Radiation Belt Storm Probe, or RBSP, mission was slated to blast off early Thursday, August 23rd, from Florida's Cape Canaveral Air Force Station atop of a United Alliance Atlas V rocket. But on August 18th, technicians detected the anomaly in another Atlas V during tests at ULA's Alabama factory, officials said. The mission will now launch on Friday morning, August 24th, with the window for a liftoff opening at 4:07 a.m. Eastern Daylight Time.
During the course of geomagnetic activity, disturbances caused by flares on the sun by big blobs of plasma coming out from the sun towards the Earth. The Earth's magnetic field is battered and shaken. Some of that energy is captured in the Earth's magnetic field, and through a variety of processes, that energy energizes particles in the Earth's radiation belts up to energies that are hazardous to spacecraft and astronauts. The Radiation Belt Storm Probes mission is NASA's mission to study the Earth's Van Allen radiation belts, two invisible regions of highly charged particles in space that surround the Earth. Each of the two RBSP spacecraft carries 5 instrument suites and a total of 8 instruments. The two spacecraft are identical. The region of space that we're talking about, where the Radiation Belt Storm Probe spacecraft will go, is one that's occupied by communication spacecraft, by weather spacecraft, by all sorts of spacecraft that you use on a daily basis. There are 2 Van Allen radiation belts. The one closer to Earth, about 1,000 miles up above the Earth's equator, contains highly charged protons that are trapped there for years and years. The further out radiation belt, the outer radiation belt, at about 1/12 of the distance to the Moon, contains a mixture of energetic electrons and energetic ions. Both of them are hazardous, but hazardous in different ways and at different times. They're always changing, waxing and waning, increasing and decreasing in strength. We don't understand why. The goals of the Radiation Belt Storm Probes mission are to determine where the charged particles in the Earth's radiation belts come from, how they get energized, and how they're lost into space. The first use for the data from the mission will be by scientists who attempt to understand the physical processes that are occurring in the radiation belts. They'll use those data to develop models for space weather in the Earth's environment, the hazardous features that surround us. However, the data can also be used by engineers to better design spacecraft. For example, if you know how much radiation is out there, you know how thick to shield your spacecraft with walls of metal. The Earth's radiation belts pose a hazard to astronauts. A hazard because prolonged exposure to radiation can cause cancer. What we want to do is understand just how much radiation is out there and just where it is, and we can warn astronauts when to be inside and outside their spacecraft. The RBSP spacecraft are focused on the dynamic radiation belts in the Earth's inner magnetosphere. They're the only spacecraft that focus on those. Consequently, they're a critical component in the series of phenomena that link the Sun to the Earth.